Go. Good. Go ahead.
Hi, everyone. This is Ziad Shalchi, and today we're going to present our project number 2, me and Trevor.
Hey, guys.
And Lee.
Hi.
So the topic about water activity of Kroger mild cheddar compared to extra sharp cheddar cheese. Next, please. Abstract. The objective of this study is to determine the shelf life of a Kroger mild cheese and the sharp cheddar cheese depending on their water activity. And 20 samples of each of the two cheeses were sampled, and their mean correlation and t-test analysis were carried out. The water activity is directly associated with the product shelf life, owning the more water content to provide a better condition for bacterial growth, and this will lead to shorter shelf life. Next. Introduction and background. So the topic again is what is the effect of age time on the water activity of Kroger cheddar cheese. Background. Extra sharp and mild cheddar cheese have similar components, but their water activity and age time differ. So the purpose of this study is to determine the effect that age time has on Kroger cheddar cheese water activity and to show the difference between the mild and extra sharp cheddar cheese in regards to their water activity. It is hypothesized there will be a higher reduction in water activity in all Kroger cheddar cheese used for the trial over a certain period than the mild cheddar cheese.
Okay,
Next.
so for materials, obviously at the food scale, when comparing the sharp cheddar cheese, the mild cheddar cheese, the two products for this assignment, we want to make sure that they're in the same amount. We want to make sure we have paper towels to lie them down on. We don't want any bacteria, any kind of microorganisms or moisture touching any of the materials that we're using today, being that we're looking for AW water activity, and we need to have that in control so that we don't affect that variable. The biggest thing is the retronic hydroscope, which is basically the machine that measures water activity for any kind of food. And this is basically putting the machine inside a probe, analyzing it in Windows computer, and using that hydroscope to actually extract out the exact AW percentage, also temperature, and then also different other things that have to do with that as well. But gloves, we need a knife to cut it, containers, small and large, to store them in properly, and especially in the fridge. And then the mild cheddar cheese and sharp cheddar cheese, 2 ounces. For the methods, we want to take the retronic hydroscope. Basically, it's a capacitance type hygrometer. For the results that we got, we want to do 6 trials for the control, the mild cheddar cheese, and then 6 trials for the experimental group, the extra sharp cheddar cheese. We want to calculate always for a Q-test, because the Q-test is going to tell us if there's any outlier data points that are completely off reading for the hydroscope. And we compare that to the Dixon chart. The hydroscope works by, like I said, connecting to a probe that connects to the computer using USB. And you just honestly run a quick 4-minute AW water activity test on Windows. And then the variables we're testing for that Leah will tell you about in the results are going to be the mean water activity, the standard deviation water activity, the coefficient of variance water activity, and then the t-test water activity, and then the t-test temperature, testing for consistent temperature basically on all trials.
Hi there. Okay, so I was in charge of the results section. And so like Trevor said, so for the results in the trial, we did 2 trials. We had a control, which was we also had an experimental group. We had a mild cheddar cheese and a sharp cheddar cheese. We did 6 trials with the cheddar cheese, 6 trials with the sharp cheddar cheese, and we got the mean, the standard deviation, the coefficient of variation, and the t-test all for each of them. To make here, right here is a little bit of a chart, but to make it easier, I made graphs to show the water activity level. So this right here is the mean of the water activity level for mild cheddar cheese, which is 0.977. That's the mean for the 6 trials. And the mean for the 6 trials of the extra sharp cheddar cheese is 0.98. So then for the next graph, and then Trevor's going to discuss the results next. I just made the charts and kind of collected the results and the data. And so the standard deviation for mild cheddar is 0.0051, and you can see how that's less than the standard deviation is 0.0077 for extra sharp cheddar cheese. And then the coefficient of variation for mild cheddar cheese is 0.517. And the extra sharp cheddar cheese coefficient of variation is 0.804. And yeah.
Yeah, so basically getting that data together. Thanks, Leah. So for the mean water activity, like she said, it was that's the biggest message here. So it's 0.9773 for the mild cheddar compared to the sharp cheddar at a 0.9580. It doesn't look very big in difference between the numbers because it is 9.5 to 9.7. But the difference is here that it shows that the aging process, how they're stored, how the different water components of these cheeses differ, is that the mild cheddar basically, in conclusion, is going to have a higher water activity. And that's usually going to mean that it needs more of a storage, lower storage temperature, longer storage, more of a, it needs to be wrapped properly and not exposed to oxygen as much as sharp cheddar would, as sharp cheddar is aged a lot longer. For the variable coefficient of variance, it was 0.804 for sharp cheddar and 0.517 for mild. I think that one of the reasons as a group we found that was the inaccuracy of measuring maybe a lower grade cheese, like sharp, being that sharp is a lower water activity cheese. There could have been a miscalculation with the actual hygrometer with measuring it. Something could have gone wrong, or maybe there was an improper O-ring closure for setting this up. So basically the coefficient of variance is a lot higher. Like the data for the mean for water activity is a lot closer and similar to cheeses, but the variance measure for the sharp cheddar, it just shows that there was a lot more of variability in these all the 6 trials. They weren't as consistent as they should have been. The standard deviation, it also shown that the sharp cheddar was a lot higher as well, being that 2 standard deviations away from the mean. Sharp cheese had a further number away. They're further away at 0.077, and then mild was at 0.0052. So it was evident that there was obviously either a miscalculation with the sharp cheese, or maybe overall, and maybe the sharp cheese is just harder to calculate, being that the water activity is slightly lower. But that's out of our range of scope, maybe a grad school type project. But honestly, it's probably to do with the proper storage time, the proper incubation. The biggest factor we learned was actually the temperature that we calculated here. The t-test, AW, which is the water activity, 0.000869430521823. And then I won't read the next number, but I'll just show you guys the T-temp test. This number just proves how we want to be at a 95% confidence interval within the same temperature for all trials, and that's a consistent thing we want to keep, like the same basically. So, and we saw in the data points that the mild cheddar had a degree in Celsius higher on average, at least a minimum, than the sharp cheddar did. So this is in conclusion basically showing how temperature, pH, and also moisture levels all heavily influence water activity and water content. So when conducting this experiment in the future, we recommend having a very, very stable room temperature, checking it often, storing properly, storing at the exact same rates, making sure those variables are exactly the same. And then basically temperature control and proper protocol is the best way to determine the water activity. And then I think it got cut off at the bottom, but I can just explain it. Water activity is mainly important for any kind of food product that goes that's regulated by the I forget do you guys know what's the thing again? The food regulation? Do you guys know it at all or no? I forget the name of it. That's okay, it doesn't matter. But basically, yeah, water activity is going to be the proper measuring of the water content so that you can understand how long something can be stored, how long it can be there, how it affects the biochemical, the physical properties, the texture. It influences everything, especially if you have something that's stored in a fridge or not. So that's basically what we learned from this experiment with these numbers, is that water activity is a public safety protocol basically for the public when it comes to food. So thank you guys for this presentation. And then I think that's about it.
Thank you.
Okay, I'm gonna stop this right now. Hold on.